Hello everyone, my name is Joseph Corson, channel is called Ethernet. In today's video, we are gradient boosting the last decision tree that we made. Video should have just gone up, should actually still be processing, in fact. But I was planning on just pre-recording the last few videos, banging them out so that way I could just enjoy my Christmas week and still have uploads for you guys. I'm gonna take a huge hiatus from YouTube after this. Yeah, for sure, but by huge hiatus, I don't know how long it'll be. Regardless, though, we're just building up on last video's code right now. So we're going to be gradient boosting the last decision tree that we made. This is my X. I'd appreciate it if you guys want to follow this, learn more about stuff that I'm doing, get some sneak peeks before anybody else. I changed that algorithm so much. It might not even look like that now. Regardless, though, that's that. And this is the current algorithm that I sell with LuxAlgo. If these numbers turn you off, don't worry about that because I have an update with LuxAlgo coming up pretty soon. That should make it a lot more visually pleasing. Let's hop into some code, though. Gradient boost the prior decision tree. Sweet. We're just going to hit it. Everything, all the other code is entirely the same, right? We just have this decision tree class, which is like the overall arching engine, our node, our get data code, all these imports, lovely. And then everything in here is the exact same logic. But we're using a gradient boosted decision tree, not just the regular one. So yeah, let's hop into this class and see what's going on. So we have the number of estimators. How many other trees are we using in this? That'll make sense later. Our learning rate, max depth, and the number of trees, or the trees as a list. So when we have our data and we want to fit it, we get our tree, or we initialize our trees to just be an empty list. We're going to say self.ymean is the mean of our y data to use that for linear regression. And our y prediction is np.full like y mean. Full like returns an array, and return a full array with the same shape and type as the given array, just to make sure that we don't have any issues in doing things like this. It'll always sync up pretty much. So for the amount of estimators that we have, we're going to compute the residuals. So y minus y pred is our error. So then we're going to get a decision tree of max depth, fit the tree to x, our x data, append that tree, update it. So learning tree times predicts that x, and the y pred plus equals that update. So now we're going to do that for every single decision tree that we have, right? Because this is our residual is y pred. So instead of our training process just being with like the same tree over and over again, like neural networks, I think it's way easier to visualize this. For a neural network, you do a forward pass through the list or through the nodes, neurons, whatever, and then you say, okay, this is what I was trying to predict. This is what I did predict. How wrong was I? That's my error. And then you go backwards and update weights and biases according to that error. This is the same process. Actually, it's not the same process in the slightest. It's the same process in the sense of this is how we're getting our information better, but we're using decision trees instead. So instead of forward passing through neurons, like with a neural network, we're making an entire decision tree model and predicting. So that way we're going to multiply by a learning rate, and then that's our update. So we're going to train based on residuals, based on our errors, and then update those errors for each model. So that way we're not doing a redundant task. I hope that makes sense. Yeah, I hope that makes sense. Instead of our loss being based on the data that we already have, and that's what we're using to get our overall last prediction, we're going to have one model, our gradient boosted decision tree. And that model's output is going to be based on the output of a bunch of other different decision trees. And those different decision trees are going to get fit with those errors. Residuals, errors, interchangeable. So when we update the residuals, we update our errors, we should progressively be getting more and more correct. And so then the last decision tree, ideally, should have to do the least amount of work. And so we're going to store, where is it? Self.trees. Where do I do it? Right here. Self.trees.append tree. So that way when we predict, Again, ypred, get a array like this shape, right? Because given shape and type, so we have our shape and we have that. So then for every tree, we're going to get a prediction, which is going to be our learning rate times the tree the tree multiplied by the prediction for x. So then that is going to be our actual prediction, is that overall entire thing. So we're going to use every single tree that we just trained on errors. That's what we're going to use, because this x is not the same as this x, don't worry. So that's not a problem. We're going to use that same tree that we're going to use all those different trees that we just trained on other trees, the prior trees' errors. We're going to use every single one of those to predict current information. This should lead to information being very contextualized. I should have started this running a while ago. You can see I've already tested it, because it does take quite some time. Because we have, where am I going? We were going to make 5 of these decision trees, and then go through and make sure that go through, check our residuals, all that good stuff. So yeah, waiting for this to run now, and hopefully shouldn't be too much longer. We're going to see in the output that it's way smoother. I guess is a good word for it. It's going to be way smoother than the prior videos, if you guys watch that. This is taking quite some time, though. I should have started this before I why can't I talk? Should have started this before I started yapping about everything. But I should have also just made this too for the sake of the video. It's alright though. I hope that this made sense. About if you guys watched the video about gradient boosting on neural network 2, I think that's my best video on this channel. One of the best. Up there with the Monte Carlo option pricing video I did a while ago. I dropped so much just sauce in that one. It was so good. I think that one was up there, and it's also gradient boosting, so you can hear gradient boosting in the topic of training on residuals or errors. You guys could hear that spoken about in a totally different context. Still waiting. See, this is what, there we go. That's when one takes aren't the best, but it's all right though, because here we are. Let's just look at this. So we can see prediction is always bearish, 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 crossover. We actually barely negative. That's such a small number, and then it continues going up. So yeah, this is just using a bunch of other different decision trees mistakes to train a huge model, pretty much. To train other decision trees off of, so that way we can just have a way more informed prediction. But yeah, that is what this video is all about. That's what we just accomplished. So here we go. Hope that you guys really are learning some valuable stuff in this series. A lot of support on it, so thank you a lot for that. I suppose a cool thing to do would be to try to, I'm not even sure how you would do it. I'm not even sure if it's worth trying to do, even to try to see if there's some sort of greedy way you could do this, so that way you could only retrain where it's worth retraining. You could add like dropouts, maybe. I don't know if dropouts are even contextual to a decision tree. Regardless, though, that's what this video is about. I hope that you guys enjoyed it. Next video is going to be all about XG boosts, so hopefully you guys stick around for that, and then we're going to be all done. So, yeah. I hope that you guys enjoyed this video. I am going to go record those other 2 videos. I'm going to be in the same outfit. So I do own a washing machine. I also just own a lot of black tees and like this hoodie. Yeah, I thought about that as I was recording videos. It's like, I probably look funny. Always in the same black tee, this hoodie. I just got a haircut, so now I look less scraggly like that. But yeah, I'm gonna get out of here. Hope you guys enjoyed this video. Hope that you guys stick around and watch the next video about XG boosts. So yeah, goodbye.